Hello and welcome. We're gonna do some math time. Here we go. So we're gonna look at ratios. We just finished up fractions. We're gonna take a look at some ratios. In particular, 2.4 in your Google Classroom here. And I want to look at this first question. In particular, the idea of a ratio is it's like a recipe. And if you mess up the amounts, then your recipe will not turn out well. That's the short version. So these are actually considered, it's called a ratio, and they are locked together. So if you make a change to one, you have to adjust the others to keep them all in what is called proportion. Proportion, it's over there, definition. Now, the way to keep all these together is by keeping in mind what's called a scale factor. If this sounds familiar, we used a lot of the similar techniques when we were doing fractions. So, our question is as follows. Michael has a summer job as a bricklayer's assistant. He's responsible for mixing the concrete. Concrete is made up of cement, sand, and gravel in a ratio of 1 to 3 to 4 by mass. Michael needs to make 80 kilograms of concrete. Okay, whoa. What this means is it doesn't give us the actual amount that this recipe makes. Most of the time you make cupcakes, it'll tell you makes a dozen cupcakes, right? This doesn't actually tell you that. So you gotta kinda track that yourself. So let's track this. So it takes let's say Michael just did concrete and he made 1 kilogram of cement. He's got 1 kilogram of cement. And he's got 3 kilograms of sand. And he's got 4 kilograms of gravel. And that will make your concrete. But if you pile all of that in a bucket, how much concrete do you actually have? I'm actually asking. Go ahead. We'll even make this the first of the DJQ. Go! What is 1, 3, 4? It equals 8. It doesn't equal 80 like is shown on here. So I'm gonna jump over to our document camera and we'll take a look. So here we've got 1, 3, 4. Add them all together. These are all the ratios. And our final recipe, it's like an unstated total, right? So our total, if I added all these in a bucket, a big bucket, would be 8 kilograms. I'm a little sad nobody typed that into chat. Come on. I know I'm recording, but you're still part of this 8-6. All right, so that's kind of our recipe. And on the previous page, it was a bit incomplete. It didn't give you that total. Michael, I think that was his name, needs to make 80 kilograms of final product. That's the total right there. 80 kilograms, right? He needs to make 80 kilograms. If he just combines them as it is, he gets 8. So how do I get from here to here? Go. There we go. Starting to see some answers. So there's something going on here, and it kind of reminds me of fractions. You gotta ask yourself, what did I do to this? What did I do to my original total to get my new total? Right? And the answer is, it's increased by what is called a scale factor. I've now drawn where I need to draw, but you get the point. It's 10 times, right? So, I increased this by 10 times, so that means I need to increase this gravel by 10 times as well, giving me 40 kilograms. Sand needs to increase by times 10 to be 30 kilograms. And my cement, my Portland cement, gets to increase by just 10 kilograms. Now, I know some of you are thinking, okay, I get this. This is straightforward. But what's the point? And that kind of ties back to my earlier thing. that I always am struggling against is when people ask me,
Mr. Cleland, when are we ever gonna actually use this? I mean, can't I just pay somebody to do this for me?
the answer is yes, you can pay someone to do this math for you and to do this work for you. Or, and this is key, you can do it yourself. So, what I mean by that is I'm going to show you when I did exactly this in my real life. For realsy. Right here. Doesn't look like much, but that's my basement floor. Okay? Literally 15 feet over there. Okay? Not even. Like 10. So, I had a problem in my basement. Okay? And that's the problem. It was this big thing, and then a pipe, and I could have paid somebody to come and do this for me. That would have been fine, right? I could have. They gotta chisel out that giant thing, get the giant jackhammer, and like take all the bits away and dispose of them, and then they'd have to mix up some concrete to patch that little hole, and another one that you can't see, but it's right about there. And I could have paid someone. This probably would have cost somewhere between $800 and $1,200 for about a day worth of work. Right? One day, that much money. Or I can do this myself. You gotta know what you're doing. You gotta have protective equipment. You gotta do this safely, and you don't want to mess around with this stuff. Do not do this at home if you don't know how to do it. And obviously never mess with plumbing or electrical. All right? Or structural. Right? This isn't that. This is just a little hole in the basement that needs to get filled with concrete. So, here's what I did. I rented that jackhammer, which was fun, by the way. Oh man, that thing's like, it was crazy. Wearing like steel toe shoes so I don't like shatter my foot. Gloves, the whole deal. You can see gloves, goggles, breathing mask, the works. Being extremely safe. And once I finally dug the hole, I had to fill it. But I don't want to go and buy 1 kilogram of Portland cement, 3 kilograms of sand, 4 kilograms of gravel, and mix up 8 kilograms of concrete. I don't need that much. It's just a little hole. So I needed to do this kind of math in my room to actually save what amounted to about $1,000. This is real math. This is legit. I've done this. So in the end, I didn't want 80 kilograms and I didn't want 8 kilograms. I wanted about 3 kilograms worth of concrete. So that's my goal, is to get simply 3 kilograms of concrete. You weren't there, so I had to do this myself. I'm gonna get you to figure out how much cement, how much sand, how much gravel did I need to get 3 kilograms so that I could patch my basement floor. Go. What amount of cement, sand, and gravel do I need to make 3 kilograms? This is a DJ cue. This is a DJ cue where we do math for songs. It didn't work. Please put your answers below the little line in the chat. Now you can solve this multiple different ways. One of them is to determine what is your scale factor and then use that, just like we did here for the earlier example. Another way to do it is, ready?
Fractions.
Thank you for posting your answers. I see them. Keep them coming. Hey, I haven't seen that method before. I like that. All right, we're gonna come right back. Let's figure out how to do this. Then I'll play the DJ cue. I'm gonna put the line cutting off the answers in 5, 4, 3, 2, 1, and done. Woo! Just under the wire. That was good. All right, so I'm just gonna take this up real fast, show you 2 ways to do it, and then we'll play that DJQ. We could do the scale factor way, which is what we did before. We determined it was 8 times bigger, and then we could do that. But this time it's reducing. So you can treat this, there's a couple ways to do this. You could treat it like division, or you could treat it like multiplying. What I'm gonna do is take what I know about my total, that 8 kilograms, and I'm gonna figure out what that would be in relationship to the 3. Now, there's a couple ways to do this. One way to do it is divide the 3 by the 8. Treat it a bit like a fraction. 3 divided by 8 takes a little bit of time. As a decimal, that is 0.375. 0.375 could be your scale factor if you were multiplying. If you were dividing, it would come up with a different number. Does that make sense? So now, I've got my new scale factor. And by the way, if I'm multiplying it by this, you'll notice this the cement is what they call a unit rate. So it starts at 1. So whatever you put the scale factor through, that's going to be your answer. So my answer for cement is right there, which is why I wrote it here. 0.375. I need to do the same thing times 3, which gives me 1.125 kilograms of sand. I do the same initial scale factor, 0.375, times 4 to give me 1.5 kilograms of gravel. And that, I can check my answer by adding all the cement, sand, and gravel together to see if it adds up. Hey, look. That adds up to 3. Perfect. So that is me doing it and checking my answer. There is another way. Do you want to see it? That clear as mud? Yeah? Okay. So let's try this again. This time, I'm going to do different fraction math. You ready? Ready? Here's the other way. So I'm going to ignore some of these. Let's pretend for a minute. I'm going to stay with that total. So 8 over 80, right? I know that total. I'm going to treat it like a fraction. 8 over 80. Okay. Is equal to what? Is equal to, I'm going to pick one of these. Let's do sand. So we're going to pick sand. And I'm going to go, my ratio for that is 3, but I don't know what the new transformed version will be. Does that make sense? So I will then just put in a variable in its place. Okay? So I can now use this relationship and I can cross multiply to find my answers. I could also reduce beforehand if I wanted to, but I'm not going to bother. So boom, boom, cross multiply. We did this the other day. So what we end up with, I'm going to grab my calculator so I do the numbers right. So I done do the numbers right. So I go 8 times n gives me 8n on one side. On the other side, I go 3 times 80. I know, that's pretty easy math. 240, right? Okay, I don't want 8 times n. I just want 1 times n. So I undo the 8 times by dividing both by 8. So on the one side, I end up with n. And on the other side, I end up with... Wait, that's not right. Oh, this is back on that original question. That's why I was like, what? Why is that number so big? But you can see n equals 30. That's my sand. And on my original question, that was what we got. So you can set it up and cross multiply, or you can do the scale factor. Does that make sense? I hope so. Last thing I want to point out is there's definitely relationships here. And remember, you can compare. I'm going to turn the music down for this. You can compare these ratios to each other, which I call part to part. That's one way you can use these. Part to part, where you're comparing sand and cement, let's say, right? You could also do part to whole. All right, so part, you can compare the part, like the sand, to the total amount of cement that you're going to, of concrete that you're making, right? So you can do part to part, like comparing cement to sand, or you can compare the sand to the total amount of concrete. So part to part or part to whole. All right. So these tricks, are different ways to arrive at the same answer. Now, I believe I owe you a DJ cue, so let's go play some copyright music, which means I'm going to stop recording. Thanks. I hope this makes sense. If you have any questions, throw them into chat or throw into Google comments, and I will try to make it clear later. Okay, so Daniel Dennis needs to make 120 pancakes. The recipe for 6 pancakes is 1 cup of mix, 3/4 cups of water. Make sense? So here is our, let me just get a little closer so we can get a closer look at this ratio. So our ratio here is 6 total, 1 and 0.75 is what Dennis Daniel decided to say. So I kind of prefer to keep this as fractions myself. I think because in cooking, they don't have like 0.5 or 0.6 or any of these on the actual measuring cup. It'll measure in imperial, which is all about quarter and half. So I prefer to keep this in fraction, but I think it'll work out for Mr. Dennis Daniel here. But let's take a quick look at this. I'm just gonna fly over. So one of the key things here is to keep the ratios the same, right? So as I scroll down, you'll see in this next section right here. So it's very much like how I set up on that page just a moment ago, where I've got the ratio and below it, I have the change. But in this case, instead of below, I'm gonna be doing it side to side like this. So here we have the 6. That's got to become the 120 pancakes, right? So this has to transform into 120. Then the 1 will transform into this, and the 0.75 or 3/4 will transform into water. Cool? What scale factor should I multiply this by, 6 by, to get to be 120? The answer is, as you called in chat, 20. And I guess I only left it open for a few seconds, so that'll be our next DJ cue. There we go. I'll count those 3 answers. I'll roll my D4 in just a moment. And one of you gets to be our next DJ cue when I'm not recording. Oh, fine. Yeah, you can jump in at the very end there. It's numero dos. You read the bottom of a D4. Okay, number 2. Number 2. That would be a person. We'll come back to that in a sec. All right. In the meantime, so you know that you need 20 times, which means if you're timesing it by 1, so in terms of mix, you need 20 cups of mix times 0.75 times 20. And you, luckily for Dennis Daniel, you end up with 15. A nice, easy number. But if you're doing this by fractions, yeah, it doesn't always end up as a nice, clean decimal, and then you gotta figure out it is a fraction. You gotta dig through the drawer, looking for the tiny little cup that's the right size. Maybe it's all worn off, so you can only infer what the size is based on the one that still has writing on it. I've gone too far. Anyway, this is how you can solve this problem. Make sense? Now, you can still solve this problem the exact same way I mentioned before, either part to part or part to whole. You could also solve it by cross-multiplying. There's all kinds of ways to adjust this. All right, thanks very much for watching. If you have any questions, make sure to hit me up in Google Classroom or the next Google Meet that we have. You're welcome to try different methods. I'm always learning new ones myself, and I hope we can share that together. We'll see you tomorrow.